everyone, welcome to Vedantu JEE English. I'm Diksha, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to all of you or not. Hi everyone, welcome to Vedantu JEE English. I'm Diksha, your chemistry master teacher. So, okay, sometimes it's weird to hear your own voice. Yes. So everyone, how are you all? Back to the studio. So are you all fine? How was first lecture of chemical bonding, right? So today is the second lecture and the game starts here, right? Today's lecture, the next lecture, the next to next lecture. Every single thing in this chapter is extremely important, right? Okay. So what we are going to talk about in today's lecture, we'll discuss some of the very basic things, right? Firstly, we are going to discuss about covalency. Then we will move forward towards the modern approach, right? So there are different sequence of doing VBT, Vesper and hybridization, right? So how I am going to teach you is the best way to understand things properly is, firstly we will understand little bit about VBT, then we will see hybridization, then we are going to incorporate Vesper into that. So that's how we are going to study this particular theory. Today's and the next lecture is totally in sync, right? Because if you miss today's lecture, next lecture is going to be waste. If you are watching today's lecture and you don't watch the next lecture, then there is no use of that, right? Okay, right everybody? So I have divided into two parts, right? So first part we are going to discuss today's class. But before that, right, spam the chat box with green hearts, everyone, right? So, and last class homework answer I have already given you here. For first, D is the correct answer, and for the second, C is the correct answer, right? It is based on pseudo-noble gas, right? Now we are going to discuss about covalency in the starting, right? Okay. To study organic, please ma'am. Mild tunes, wait for just 3 days, right? From the next week, I am going to start GOC, and that is how you start organic chemistry, right? Okay. So after this, my full focus is going to be on organic chemistry, right? Because P block, see, inorganic chemistry we have done, only P block is left, and chemical bonding I will do that, right? Like in 2 days I'm going to finish that, right? We are left with only P block, and P block I will do in the end, right? Then in physical chemistry, 2-3 chapters are left, right? That's it. We are just left with organic chemistry part. So next goal is full organic chemistry, right? Next 20-25 days we are going to study only organic chemistry, so don't worry about that. Right now just focus here, okay? Your full focus should be here. Because if chemical bonding is weak, automatically GOC will be weak, and automatically organic chemistry is going to be weak, right? So for that, your chemical bonding has to be very strong, right? Let's understand that. So firstly, let's talk about covalency. Covalency, it's a very simple concept, right? That is the number of covalent and the number of coordinate bonds, right? That you're going to form, right? So maximum covalency of an atom is the total number of covalent and coordinate bond that it makes. That is your covalency. So one by one, we'll talk about different covalencies. So let us firstly talk about beryllium, right? Okay. So now in case of beryllium, what you have? Hydrogen, helium, lithium and beryllium. So let's talk about lithium firstly, okay? Let's talk about lithium. So in case of lithium, it is atomic number 3, so it is 1s2, 2s1. That means this kind of orbit you will have here. This will be 1s and this will be 2s, right? So in the ground state, you have 1, 2 and this is 1. Now, even in the excited state, the outermost, so whenever you jump from ground state to excited state, always the outermost orbital, right, that electron will jump, right? Innermost electron will not jump, right? The core electrons will never jump. So it's already unpaired. It's already unpaired. That means here it is going to form a bond with this particular. Now whenever we need bond, okay, whenever I am going to talk about bond, right, whenever we are going to talk about bond, covalent bond or coordinate bond, what we need for covalent bond, so I'll just write it here. I'll just write it here. For covalent bond, what you need? For covalent bond, you need half filled orbital, you need half filled, whether it's in the ground state or it's in the excited state, right? And when I talk about coordinate bond, you need empty orbital. This is what you need. And both are in the outermost shell. Both are in the outermost shell. Outermost shell. This is what we are going to talk about. Right? Okay. Now, let's see this. Now guys, when I talk about, now you have to understand these things very carefully, otherwise VBT, Vesper, all these things will go out of your head, okay? VBT, Vesper is not difficult at all. It's just that these concepts, if you have good hold over, then VBT, Vesper is very easy. Then even coordination compound will become very easy for you, right? So ground state is 2 electron here and 1 electron here, right? And that's how you have. Now we know that because of this 1 electron, it can make 1 covalent bond. So maximum covalency is 1. For lithium, maximum covalency is 1 because it is only able to make 1 covalent bond. 1 covalent bond. Okay? It is only able to make 1 covalent bond. Now let's discuss about beryllium. Beryllium is what? Beryllium is hydrogen, helium, lithium, beryllium. It is 4 atomic number. So it will be 1s2, 2s2. Right? So you will draw it here. This is 1s, this is 2s. And when you fill the electrons here, it will be like this. This is in the ground state. Now you are like, ma'am, but for coordinate bond or covalent bond, what we need is empty or half filled orbitals. Now this is the outermost orbital. This is not empty. This is not half filled. That means this will not make any bond. No. In reality, BeCl2 exists. That means beryllium forms 2 bonds. Okay. That means it is not able to make a bond in which condition? In the ground state. But in the excited state, what you will have? In the excited state, what you will have? This will be 2p. Okay. So this is 1s, 2s and 2p. Inner core electrons will never jump. Only the outermost electrons will jump. So 1 electron will jump, right, because of excitation. 1 electron and 1 electron, and that is where this bond formation will occur, okay. So to this and to this, 2 bonds will be formed. 2 covalent bonds. 2 covalent bonds, okay. Now, can you see in the outermost there are 2 empty orbitals as well? So these 2 empty orbitals here, this empty orbital and this empty orbital, because of that empty orbital, it is also going to make 2 coordinate bond. 2 coordinate bond. And that's why the maximum covalency is going to be 2 plus 2, that is 4. So 4 is the maximum covalency here, right? 2 covalent and 2 for coordinate, right? Okay, understood? That's why this will help you to understand the VBT theory of chemical and coordination both, right? Now, if you talk about after beryllium, what you have, let's talk about boron. If you talk about boron, right? Boron is atomic number 5. It is 1s2, 2s2, 2p1, right? In the ground state, and this is in the excited state. In the ground state, you have 1s, 2s, and this is 2p. This is 1s, 2s, and this is 2p. So in the ground state, what you have, you will fill it just like what is given here, right? In the excited state, this 2s electron will jump, right? This 2 electron will jump here, so it will be 1, 2, 3, and that is the reason it will form 3 covalent bonds. 3 covalent bonds, and this will be the coordinate bond. This will be the coordinate bond. Okay? So that is the reason covalency is going to be, 3 plus 1, 3 plus 1, that is nothing but it is 4. Right? Thank you so much. Thank you, Trimul. Thank you so much. Okay. Got it? Now, do you know what is the definition of Lewis acids and Lewis bases? Lewis acids are the one which can donate the electrons. Lewis acids are electron deficient, right? They can accept the electron, right? So can you see in this how coordinate bond will be formed? 2 electrons will be accepted. 2 electrons will be accepted. That means beryllium is a Lewis acid. Beryllium, when it forms BeCl2, it is a Lewis acid. Can you now see why it's a Lewis acid? It is a Lewis acid because it has 2 empty orbitals for the formation of coordination bond, and that is the reason that it can accept the electron. It is electron deficient, right? Similarly, in this case, it is also acting as, that's why BF3, BCl3 all are Lewis acids. All are Lewis acids. Got it? Yes, everyone? Now, similarly, let's talk about carbon. 1s2, 2s2, 2p3, 2p2, 2p2, right? Now, in the ground state, you will write it like this. In the excited state, we will see how you will write it, okay? So, in the ground state, you have 1, 2, 3, 4, 1, 2. In the excited state, it is going to be this. And that is why carbon forms 4 covalent bonds. 4 covalent bonds. And that is why covalency of carbon, right? Covalency of carbon, maximum covalency is going to be 4. Can you see in period 2, most of them are having 4 covalency, right? Now, is this as Lewis acid or a Lewis base? For example, CH3, it is not a Lewis acid, neither a Lewis base. It is not a Lewis acid, not a Lewis base. Nothing it is, okay? Because it is sharing the electrons. Now, let's talk about nitrogen. Nitrogen is 1s2, 2s2, 2p3 because the atomic number is 7 in the ground state, and you will have this in the excited state. Let's see. 1, 2, 1, 2, 1, 2, 3. Now, what will happen? Right? Now, what will happen? Can you see? If you feel like, ma'am, it will jump to which one? To 3s? No. It tries to remain in the same shell, right? So, it will not jump to 3s, right? So, that means it will remain the same in the excited state also. Whether it's ground state or excited state, it will remain the same. So, I can see 3 covalent bonds you have. Tell me, is there any chance of coordinate bond here? Any chance of coordinate bond? Yes, everybody. 2, 3, 4, very good. Any chance of coordinate bond? Let me see who can actually answer this. Always remember, this has a lone pair. Whenever nitrogen, it is connected to 3 bonds when it is making, it always has this lone pair, and these are the lone pairs that we are talking about. These lone pairs, do you remember when you have NH3, this ammonia, this lone pair can be donated to a electron deficient. For example, let's say this is NH3 and this is BF3. So these lone pairs can be donated here, or you can also write it like this. This is the actual base of organic chemistry. In fact, general organic chemistry, if you know this, then only you will be able to understand general organic chemistry also, right? So chemical bonding, how you study it, that matters a lot, right? So now this is actually a Lewis base, which is electron rich. This is a Lewis acid. This is a Lewis acid, which is electron deficient. So this lone pair here is going to make coordinate bond with any Lewis acid which is electron deficient. It will donate its electron. That's why covalency is going to be 1 plus 3, that is nothing but 4. Is that clear to everybody? Is that clear? Right, everyone? So these concepts, very beautiful concepts you have in chemical bonding. This will open your brain, like what is happening, right? This is so beautiful, right? Let's talk about oxygen. 1s2, 2s2, 2p4. Now why I am repeating these things? Because every single time you are learning something new, right? So 1, 2. Acha, this you should be very comfortable in drawing these things, okay? So this is 2 electrons here, 2 electrons here, 1, 2, 3, 4 electrons here. Now it does not have 2d, so the electrons cannot be jumped to an excited state. So this is the ground state, this is also the excited state. This is the ground state, or this is also the excited state, right? Now here these two will form 2 covalent bond. And do you know in oxygen, always when oxygen is forming 2 bonds or 1 double bond, it always have 2 lone pair of electrons, and these are those 2 lone pair of electrons. That's why it is electron rich, that's why it is acting as a Lewis base, and these 2 coordinate bonds can be formed. So what is the covalency? What is the covalency? It is going to be 4. 4 is going to be the covalency here, right? Last one, let's discuss fluorine here, right? Fluorine is atomic number 9 and it is going to be this. Now 1 is, 2 is and 2p. Let's see, 1, 2, 3, 4 and right. That's why fluorine only makes 1 covalent bond. Only 1 covalent bond. How many coordinate bonds it can form? It has 3 lone pairs, it can form 3 coordinate bonds, okay? Now don't take, this is not a lone pair. Outermost will be the lone pair, okay? That's why I am teaching you all of this, so that you get comfortable when you study VBT, right? So this is your 3 coordinate bonds, right? And what is the covalency? Covalency is going to be 3 plus 1, that is 4. Right? Wait a minute. No. Covalency will not be 4 here. It has 3 coordinate bonds. So now you tell me one thing. Will fluorine is a very electronegative element. Very electronegative. So fluorine having so much electronegativity, it's like I am very clever. I don't want to give my electrons. It's like someone who is very rich and still they don't want to donate anything. Someone who is extremely rich. But even if you ask them for 10 rupees note, they'll be like, I can't give it, I am very clever, I am very greedy, right? So that kind of person fluorine is. So even after having 3 lone pairs, but do not participate in bonding by donation. Why they don't donate? Because it is highest electronegativity. Because of its such high electronegativity, even after having 3 lone pairs, it is not able to donate, and that is the reason HF is not a Lewis base. It is not able to donate the electrons. Okay. Now, if you see this, here we will write covalency. Covalency is going to be 3. Is going to be 1 only, right? Covalency is going to be 1. Got it? Right? So what we talked about here, that in the second period, lithium has covalency 1. I'll just write it here 1. This is 4, 4, 4, 4, 4, and this is 1. So it is generally said that, second period has covalency of 4. It is generally said that second period has covalency of 4. Right, everyone? Tell me if there is any doubt in covalency. Right? So for third period, I will not get into this. Just remember that the maximum covalency is 6. Due to presence of d orbitals. Okay, let's not get into it. It's more of a part of coordination chemistry. So we'll focus on only second period elements. Okay, right? So here for third period, maximum covalency is 6. Okay, so you can write it here. Okay, maximum covalency is going to be 6. Got it, everyone? Correct? Fine? Yes, everyone? Can I expand its octet and its maximum covalency is 4? Then how can it show plus 5 oxidation state in N2O5? But your oxidation state is something else. Oxidation state is loss of electron. Right? Okay? Oxidation state is something else. Now this you will see in, I have seen your doubt, okay? If you talk about P block, right? If you have seen periodic, I have already taught you periodic classification, right? In periodic classification, we have studied that in front of these or before boron, carbon, nitrogen, oxygen, fluorine, there is no element which has d orbitals, right? That's why it cannot expand its covalency. But third period elements, because of presence of d orbitals, they can expand their covalency up to 6. Okay? Yes, everybody? Right? Oxidation state is a different thing. Right? Covalency is a different thing. Right? Now, the second concept of today's modern approach. Modern approach. modern approach. Let's talk about this. Yes, everyone, let's talk about the modern approach. Ready? Okay. Okay, yes. So, modern approach is what you're talking about, unnumber average vector is 2. Chalo. Let's talk about it. Guys, shall we start with modern approach? Now, in the octet rule, we discussed about that how to complete their octet, to have that noble gas configuration, right? They all were losing and gaining the electrons. But there were so many limitations for it, right? So that is the reason that now we are going to talk about the modern approach. In the modern approach, what we have is, they are saying that in an atom, let's talk about hydrogen. You have 1s1. So in hydrogen, you have 1 electron, you have 1 proton. In other hydrogen, you will have 1 electron, 1 proton. Okay. Let's see, this is the electron of one hydrogen, this is the electron of other hydrogen. This is the proton of one hydrogen, this is the proton of other hydrogen, right? So you have 2 electrons and you have 2 protons, right? 2 electrons and 2 protons, right? In total, in a H2 molecule. Right, so we are going to discuss what exactly is happening here, that it is making a bond, right? So firstly, let's talk about, there are so many attractions and repulsions that are taking place here, right? What are these? If you talk about, this proton is actually getting attracted with this electron, they are getting attracted. This electron is getting attracted with this proton. So one electron, this electron is feeling attraction from this proton and this proton, right? Okay. So if I say that, let's say you have hydrogen 1, let's say you have hydrogen A, which is having electron A and proton A. You have hydrogen B, which is having electron B and proton B. So the attractive forces that you can see, are between electron and proton. So electron of A and proton of A, and electron of B, electron of A and proton of B, electron of B and proton of B, and electron of B and proton of A. So these are the 4 attractive forces. This electron is attracted by these two, this electron is attracted by these two. So these are the 4 attractive forces that you can see here, okay? So to make it better, I'll just write it like this: EA with proton of A, EA with proton of B, EB with proton of A, and EB with proton of B. Okay, that's how you're going to write it. Now the repulsive forces, when there is repulsion, so repulsion will be between which of the two things, right? Repulsion will be between this electron and this electron, this proton and this proton, right? So repulsive forces are electron of A is repelling electron of B, proton of A is repelling proton of B. So these are the repulsive forces. These are getting opposite, these are repulsive, right? Positive repelling each other, negative repelling each other. So firstly, we know that, now understand that whenever there is bond formation, there is attraction and repulsion, right? Now let's understand this with the help of our life. When you see someone, right? There's someone that you have always imagined, right? He will be so handsome, she will be so beautiful, this and that you're imagining. Oh, perfect guy, perfect girl I want, right? And you see them, you're like, oh my god, love at first sight, right? So when you are getting attracted, you like, oh, how she's eating, oh my god, but I totally love her, right? Oh, what he is wearing, but I totally love him, right? So you ignore every bad thing about them, isn't it? So in the start, attractive forces are more dominating, right? You're getting attracted with them, right? But once you get into a relationship, right? Those who have gone through this, they know. Naham is actually telling truth, right? Then you're like, I'll forget about JEE preparation. Forget about this dream. I'll focus on this person, right? So much attraction you have, right? Then after that, what will happen, right? You will get to know them, you will get to know them, you will get to know them, you will get to know them so much that you will get to know that this person is not perfect. This person has so many flaws. Then you will start hating that person. Not hating, but at least disliking that person, right? Then these repulsive forces, fights and all will start, right? So this is what is going to happen when two atoms are making a bond, right? So when two atoms are making a bond, firstly what will happen? They are at a distance, okay? They are at a distance. These two atoms are separate. These two atoms are separate. They just saw each other. They're like, wow, what a person. Oh my god, I want to know this person, right? So now what is happening? The distance is going to decrease, right? So this is the distance of separation. We are going to decrease the distance, right? So here, this is the internuclear distance and this is the energy. So as distance is decreasing, right, your energy is also decreasing. Very stable you are, very stable. Always remember, energy is inversely proportional to stability. Energy and stability are inversely proportional, right? Right? Wait a minute, maybe could have told carbon silicon get covalency concept. That's why I'm saying. Check this, she said it's what? Yes, for oxygen beta. What is covalency? Starting me, you have not seen what I told you. I told you covalency is covalent plus coordinate, right? You're just focusing on covalent bond. Beta, oxygen can make two coordinate bond. Coordinate bond is formed when you have empty or fully filled orbitals, right? Empty orbitals will accept the bond, fully filled will donate the bond, right? So these are going to make two coordinate bonds, and these two, because of half filled, they are going to form two covalent bond, and that's why covalency is 4, right? Okay, 4. It's 4. It's 4, guys. It's 4. For fluorine also it should be 4, but because fluorine also has 3 lone pairs, but fluorine is highly electronegative, so it is not interested in donating the electrons, right? So that's why it will not form covalent bond, it will not donate its lone pairs, and that is why it will form only one covalent bond. That's why covalency is 1, right? Okay, right everybody? Tell me. Yes, everyone, tell me, is that clear? Yes, Anjali. Tell me, were you sleeping when I was teaching you this? Huh? I've clearly mentioned here. Total number of covalent plus coordinate. That's why I tell you, please focus when I'm teaching. Focus should be here and here. Listening and watching what I'm teaching you. Right? See, this is what I have told you. Then if you don't know this thing, then I think you don't know the covalency concept. Then whatever I have taught you, you need to watch that again. Okay? Right? Then watch again what I have told you about covalency. Now, when I will complete this concept now, after 10 minutes you will ask me, ma'am, but what about, ma'am, energy instability, ma'am? Then I will again come back and teach you. Achha, you were late. So, covalency, watch it after that. Okay, ignore covalency for now. Watch this concept now. Okay, watch this concept. Otherwise, what will happen? I'll tell you this concept. You will also have problem in this because your brain is in covalency. Then this concept also will be lost. Okay. Now tell me, is this clear to everybody? Attractions, repulsions, is that clear? At least that I can do. It's Teacher's Day. I can roast you. That much right I have over you, isn't it? Yes. You're like my little brothers and sisters, so I can definitely roast you. Tell me, attractions, repulsions. Clear? Done? Still, if you have a question on that, tell me. Right? Attraction, repulsions, clear na? Right? Now, what I am teaching you here, that energy and stability are inversely. It's such a beautiful concept. See this. Energy and stability are inversely proportional. Okay? It's like you see someone, right? You fall in love with them, right? You like, this person is the best. There is no flaw in this person, right? You're totally fan of this person. You propose them, they accept it, then you know them, then you daily talk to them, then some things you don't like about them. Then you start seeing their flaws. Then you're like, this person is not that perfect. This person is kind of irritating, right? So then you are like repulsive forces, right? So this is the same thing that happens in bond formation, okay? So firstly, you are at a distance. Now you don't have any bond. You just see them daily. It's your crush and you see them daily. You're going to tuition because of them. You're going to school because of them, right? You see them daily, right? You are getting attracted. Attractive forces are so high. Because of these attractive forces, you're in a stable situation. You're like, I'm happy, right? You're getting into a stable situation, right? The more closer you're at this distance, you're unhappy. You're at this distance, you're more happy. 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 You're at this distance, you're more happy, right? You have made a bond with them, you're very, very happy, right? So as the distance is decreasing, happiness is increasing, stability is increasing. When stability increases, energy decreases, and that is the reason energy is decreasing. And at one point, bond has formed, right? You're like, finally, this person is mine, right? This is exactly what happens, right? Students tell me, ma'am, I have ruined my class 12 because I went through a breakup. Ma'am, I have ruined my class 12 because I was so busy, chatting with someone, right? This is what happening with you. You're talking to them. You think this person is perfect. Then bond formation is there. Till here, everything is fine. Till bond formation, everything is perfect. They are in a stable situation. But if beyond that, right, it's like you know them this much. If you're like totally talking to each other day and night, you're not focusing, right? I don't even if you were my little brother or sister, I would have told you attractions are very normal, right? It's normal. Congratulations, you're a normal person, right? That's why you're getting attracted with someone, right? But okay, you want to get into a relationship, fine, get into that. But if you're spoiling your JEE preparation, everything, right? And you're talking to them day and night, good morning, good evening, have you eaten lunch, dinner, this and that you are doing. What will happen at a point? You will start like getting irritated by them, right? Repulsive forces. That's why when the bond is formed, you should stop here. You should have that space, right? But when you go beyond that, you're talking hello, good morning, good evening, good night, good morning, good evening, good night, you're doing daily, right? Then it starts getting very suffocated, very irritating, right? Now what will happen, right? Your stability will decrease. You'll start, repulsive forces will increase. More attractive forces means stability. Now you are at this point. Now you are getting repelled. You're getting repelled. You're like, this person is so irritating. So if beyond this distance, you want to know them, right? Then what will happen? Repulsive forces will start, energy will start increasing and stability will decrease. Okay? And this is the point of bond formation. This is the point of bond formation. Now understood? Why bond is formed? Bond is formed just for the stability, to minimize the energy, right? So at this distance, they were having good amount of energy. Now they minimize that energy, they are at a stable position. But if you further increase, now they already have made a bond, right? Now if you further increase the distance like that, it will cause repulsion and hence that will not happen, right? That's why till here you have bond formation. Beyond that, you won't be able to increase the distance, right? And this distance that you have here is called your bond length, The distance that you have here between two atoms, that is called the bond length, right? And at this point, because the bond is formed, so the energy that you require to break this bond is called bond energy. Because this much energy is there, this much energy is there, this much energy is there. So this much energy is required to break this bond. Okay, so that is your bond energy. Tell me, is the modern concept clear to everybody? Okay. First career, then Babu Shona. Yes. So this is a real thing that we are telling you, right? That no matter you get attracted with someone, in the end you will find flaws and then you will start getting irritated. So it's better to study, right? Because in the end these repulsions are going to happen in your life. And you think that this is just a phase that you're always going to have. No, this is the phase that you will start hating. And for this phase, right, you need career, right? So focus on your career rather than Babu Shona, okay? Chemistry is telling you that, right? Okay, yes. Yes, Unseen, that's what I am telling you. For that you need to be at this point, which is your bond formation, that's it. Beyond that, if you go, repulsions will start. Okay? Understood? Got the concept? Now I'm going to start with VBT. Understood the concept? Ma'am has a terrible story. When I was of your age, we didn't even have had Facebook. Facebook also was not there. Facebook was there, but I don't used to use it. It was not allowed. WhatsApp was not there. I didn't have phone only. So forget about these things. Right? Forget about these things. We were very lucky, right? There were no distractions. I got my first phone when I was in college, I think, yes, before college, like just after board exams, right? My parents gifted me a phone that, okay, now you have this phone. Now take this number. Otherwise, I always used to have my only mother's phone, my mom's phone I used to carry everywhere. Right? When I'm going to any tuition, I used to carry my mom's phone. That's it. Distractions were zero. Right? We were lucky. Okay. You guess my age. So now let's talk about valence bond theory. Okay? Ready for valence bond theory? That's like a limit. Yes, that's your limit. Like I'm telling you, as your elder sister, I am telling you, even if you get attracted by someone, there is a limit. When you have made a bond, then you're like, okay, this person is my friend, that's it. Then focus on your JEE preparation. If you go beyond that, you are like, hi, good morning, good evening, good night, this and that you start doing, you will start getting irritated because you will have 0 marks in JEE. And blame you will put on that person, right? So repulsions will be there. So it's better to have this limit. This bond formation is your limit. Okay? Now, yes, valence bond theory, right? So this chapter, that's why I really like it, because you can relate this to your daily life, right? Valence bond theory is, see, there are various ways of understanding VBT, Vesper hybridization, but I'm going to follow this sequence, right? So let's understand that, okay? First is, what exactly is valence bond theory? So valence bond theory states that covalent bond is formed due to overlapping of atomic orbitals, right? He said that this thing that I just taught you, that they will have a distance, then they will come closer, distance will decrease, and these orbitals, what this I showed you, this is overlapping. 2 orbitals will overlap with each other, right? And that's how they are going to form a bond, right? So this is telling you that covalent bond is formed due to overlapping of the atomic orbitals. Atomic orbitals will overlap and they will give you the covalent bonds, right? Okay. So for that we need to understand this concept of overlapping concept, okay? For that you need to understand this concept of overlapping to understand VBT, right? So overlapping, right, there are so many different ways of having overlapping, right? Because of overlapping we have sigma, pi and delta bonds. So let's discuss about that, right? So if you talk about overlapping, it is mixing of 2 atomic orbitals. Mixing means this is one and this is the other orbital, they will mix, right? A mixing of 2 atomic orbitals of 2 separate atoms, right? Of 2 separate atoms, 2 atomic orbitals are overlapping with each other. Only 2 atomic orbitals in the valence shell. Only in the valence shell they will overlap. Only in the valence shell these orbitals are going to overlap, right? Of 2 separate atoms having unpaired electrons of opposite spin. So can you see 3 conditions we have seen here? Conditions for overlapping. What are these conditions? What are these conditions? First is, it should belong to valence shell electrons. Only those electrons will be overlapped which belong to valence shell, right? Second is, it should be half filled. Third is, it should have opposite spin. These are the conditions in which overlapping can happen. For example, I have an orbital here, right, which is of plus half spin. This is an orbital which is of minus half spin. Now these two can overlap. These two can overlap, right? So the spins should be opposite. It should be half filled and it should be from the valence electrons. And this criteria of valence electrons you can see from here covalency as well. That in all these cases, if you see, I never talked about this inner core electron. I always talked about valence electrons. I always made a bond with valence electron. I always made a bond with half filled electrons, right? So can you see, now you will see, ma'am, but you also made a bond with fully filled. I made covalent bond. Here I am talking about, I made coordinate bond. Fully filled and empty makes coordinate bond. I am talking about covalent bond now, right? So here 4 covalent bonds. But this I never talked about because I only talk about valence electrons, half filled electrons, right? And if it is overlapping, it will overlap with something which is of opposite spin, right? So these are the conditions of overlapping. Is that clear, everybody? Is that clear, right? What are the conditions of overlapping? Conditions of overlapping, is that clear, right? Okay, now let's talk about the strength of overlapping, right? Lower the energy of orbitals, greater the overlapping, right? If the energy of orbitals is less, right, then the overlapping will be more, right? So that means, can you compare this with the modern approach? When the energy of orbital is less, energy has decreased. That's when stability was maximum. And that's why overlapping was maximum. Do you understand? This modern approach, we are giving it a proper theory that is based on overlapping. That why when we talk about energy that is inversely proportional to stability is inversely proportional to overlapping. So less is the energy, more is the stability, more is the overlapping between these two orbitals, right? So that's why greater overlapping. So this we have done. Energy of orbital greater the overlapping. This we have done. Okay, right. Next is greater the overlapping, greater is the strength of covalent bond, right? So can I just write it here? If overlapping is very high, then bond strength is going to be very high. Bond strength is going to be very high, right? Are you able to understand this? More is the energy, less will be the stability, less will be the bond strength, less will be the overlapping. So all these things are interrelated to each other, right? Stability will be more when the overlapping is more. Because of more overlapping, stability will be more. Because stability is more, it is very difficult to break that bond. So bond strength will be very high. Right, so that's why bond energy will be very high, right? So it all depends upon the overlapping, how much overlapping you have, right? Now let's understand this strength of overlapping with some other factors as well, right? Now which will define that energy is maximum, which will define that overlapping is maximum or minimum. For that, you need to understand the nature of orbitals, okay? So, nature of orbitals, we have two kind of orbitals. First is s orbital, then there is p and d orbital. P and d orbital. If you see this here, s orbital is non-direction, it is spherical shape. So it is a non-directional orbital. Because of its non-direction, see, I'll just tell you this thing. It exists in lobe, so you can say it is lobes, or you can say it is directional. I'll just give you one example here, right? This is non-directional. Now ma'am, how directional, non-directional are going to tell whether overlapping will be minimum or maximum? Okay, tell me one thing. If I have to overlap these two, these are direction, p orbitals are like this now. These are like this, one lobe, second lobe. This is another p orbital. D orbitals are like this, isn't it? This is how d orbitals look like. This is how p orbitals look like. D orbitals are double dumbbell shape, right? And p orbitals are dumbbell shape. Now, if I want to overlap these kind of orbitals, I want to overlap. Can you see? This is how I am overlapping this. Isn't it easy to overlap? Can you see? Overlapping can be really good. But let's say I have two spherical balls, okay? I have two spherical balls. I want to overlap them. Can you see it is very difficult for them to overlap? If I have two spherical shape, it is very, very difficult for them to overlap, right? Same thing, right? So when we talk about s orbital, because it's very difficult to overlap, so it will show minimum overlapping, and P and D will show maximum overlap. That's how, based on what kind of orbital you have, you can tell the overlapping will be good or the overlapping will be bad. Okay? Right? Okay, everybody? Okay. Yes, students? So, S orbital you have minimum orbital, P and D you have maximum overlap. Clear in everyone's head? Clear, guys? Right? Clear now? If you still have problem, then tell me in the chat box. Watch this, absorb this, and if you have problem, let me know. Ma'am, in P and D, which is high overlapping? We'll talk about that. Next 10-15 minutes, we are only going to talk about overlapping. Okay? We'll talk about different sets of overlapping as well, because for JEE Advanced you need that much. Okay? Right. Let's talk about this. Now, there are two kinds of overlapping, right? These two kinds are sideways overlapping and axial overlapping. So, head-on, coaxial, end-to-end, axial overlapping, sideways, lateral or collateral, right? Head-on overlapping is two things are colliding like this. Two things you have, if they are colliding like this, this is head-on, this is head-on, this is head-on, right? So, two things which are overlapping like this, this is your head-on overlapping, right? Now, if you talk about two things which are sideways, that's how they are overlapping with each other, right? This is called sideways overlapping, okay? Two kind of overlappings you have, one is head-on, other is sideways. Head-on and sideways. Head-on overlapping gives us what kind of bond? Sigma bond. Sigma bond is formed here because of head-on overlapping. Because of sideways overlapping, you will have pi or delta bond. You will have because of head-on overlapping, right? Pi bond you know, delta bond we will talk about, right? Okay, these two things. Now let's talk about that which is going to give you what. Okay, let's talk about that. Wait a minute. Yes. So I'll just give you, firstly summarize this thing, right? So I'll just write some orbitals which give sigma bond, which give pi or delta bond, okay? So S and S overlap is sigma bond, S and P overlap is sigma bond, P and P overlap will be sigma bond. Now P and P overlap can be pi bond also, D and P overlap will be pi bond, and D and D overlap can be delta and pi, okay? So these two will be pi and this will be delta. That is represented like this, it is represented like this, and these three are going to give you sigma, okay? Sigma. Okay, so what we discussed, we have two kind of collisions. We'll talk about what is the difference between delta and pi. We'll talk about that. Right now just focus on here. You have two type of overlap. One is sigma overlap, other is pi or delta overlap, sideways overlap. Sigma bond is formed when two s orbitals like this. Okay, they are overlapping like this they are overlapping, that is sigma bond. When this is a p orbital and this is a s orbital, it is overlapping. For example, this is a p orbital and this is a s orbital, that is overlapping, that is sigma bond, okay? And then when two p orbitals, they overlap like this, head on overlapping of two p orbitals, right? That is your sigma bond. Now when two p orbitals, they have pi bond, they will have this kind of situation. They will overlap like this, they will overlap like this, okay? So sideways overlapping, that is pi bond. Acha, when you talk about d and p orbital, d orbital will be like this and p orbital will be like this. Can you see, this is your pi bond, sideways, it's not like this, it's sideways, it's pi bond, right? It's sideways overlapping, so it's pi bond, right? Now D and D, that means this D and this D will show us sigma also, will show us pi also and delta also, that I'll talk about now. First you tell me SS, SP, PP, PP, DP, is that clear or not? Or should I just draw these things for your note? Okay, I'll just show you these things here also. Head on or coaxial end to end always form sigma bond. Now this is between SS, this is between S and P, or you can say P and S, this is between P and P, this is between P and P. So these three categories always form sigma bonds, right? Okay, got it? Right everyone? Good. Now let's talk about H2, which is going to give us SS overlapping. Now H2 has 1s1 and this is 1s1. Now to make it better to have this overlapping here, this should be upwards and this should be downwards, okay? Opposite spin, half filled, valence electrons, yes, they will overlap and they will make a bond, right? That is your sigma bond, okay? That is sigma bond. Next is HF. Now here you have 1s1 and here fluorine is 1s1, 1s2, 2s2, 2p5, okay? So in the outermost it has this thing, if you can draw it, this is 2, this is 2p, electrons are like this, 1, 2, 3, 4, 5, 6, 7. So that means this is the valence electron, this is that valence electron which is going to form this bond here, and this exists in p orbital. This is 2p orbital, right? So this exists in p orbital, and this is the let's say this is upwards, so this has to be downwards. Okay, so I'll just write it in white pen. If this is upwards, right, then this has to be downwards, right? Then this has to be downwards. They will overlap, they will form a sigma bond here, right? Okay. Third is F2. This is an example of PP overlapping. Let's talk about that. Fluorine is what? Fluorine is, as I have shown you, 1s2, 2s2, 2p5. So it will have this kind of situation, right? 1s, 2s, 2p, 1, 2, 1, 2, 1, 2, 3, 4, 5, and this is the outermost electron in each fluorine, which is the valence electron, and here it is in p, right? Condition is both of them. Right now you will ask, ma'am, whether it's px, py or pz. If I am taking, if by convention, if I am taking this as x, this as y and this as z. So x-axis, the one which is like this, that will cause head-on collision. Y-axis, if I am taking like this, so it will always, with py, it will always form this pi bond, right? So because we are assuming that this is in px, that's why. Because see, one thing clear, it should be clear in your head. The first bond, now you will say, ma'am, how can you assume this is px? Why not py, ma'am? Why not pi bond? Why it is forming sigma bond? Always remember, right? First bond will be sigma. Second bond, even if you have a choice, even if you have, let's say, a situation where you have in 2p you have two vacant orbitals. First will form sigma, second will form pi. Always. Before pi there will always be one sigma bond. Okay? Before pi there will always be one sigma bond. So that's why it is forming one sigma bond here, right? And that is what we have. Right? Okay. Now, if you talk about the trend of head-on collision, the strength of head-on collision, right? The trend is that firstly PP will have highest strength, then SP, then SS. That is the general trend, okay? PP, then SP, then SS, okay? General trend is PP, then SP, then SS. PP, SP, SS. Why? Because P and P obviously they have very good, P orbital has very good maximum overlapping it has, then S has less, and here you have 2S, so that's why overlapping is decreased. Right everyone? Shall we talk about sideways overlapping, because now we are going to talk about in phase, out phase we will talk about. Okay? Okay, yes everybody. Now let's talk about this. You have sideways or lateral overlapping. In sideways you have two kinds, one is pi, one is sigma, delta. Let's talk about that. Only p and d orbital can show sideways overlapping, forms pi and delta bond, right? Now let's talk about three categories we discussed here. One by one we'll discuss all of them. First is p pi, right? In this, they should be parallel to each other, right? Okay, they should be parallel to each other like this, okay? Now, because this is your py, this is your py, and when it overlaps, it is going to cause this kind of situation, and that is called your sideways overlapping, right? This is forming a pi bond, right? This is forming a pi bond. Let's say here you have one orbital, this is the second electron, sorry, two electrons are there. Some students, you know what they do? They'll put one electron here, one electron here. Ma'am, it is forming 2 pi bonds, ma'am. Wrong. In one lobe, you have this situation. If it is half filled, it will be like this. Only one electron here, right? One electron here. So this is not possible, right? That is not possible. Okay? Got it? Yes. Now let's talk about p pi d pi. P pi d pi is again, this is your p, right? This is p orbital. P orbital, and this is d orbital, and this is d orbital, and this is d orbital, right? Now this d orbital can be dxy, dyz, dzx, dx square minus y square, dz square, right? See, dxy, dyz, dzx, dx square minus y square, they all will look the same, right? They have 4 lobes, right? They all will look the same. Pi bond will be there. But what about, ma'am, dz square? It will be like this, okay? It will be like this. For pi bond, it will be like this. This will be dz, and this will be the cloud. This will be the cloud, right? So here what you will have, this will be the cloud, and this is the overlap that you will have. Again, this is a pi bond. So this is how you have pi bond between p pi, between p orbital and d orbital. There is no delta bond here, right? Okay, there is no delta bond here, right? Okay. Okay, yes. Now let's talk about d pi, right? In which we are going to talk about pi and sigma, pi and delta, both of them. Okay. Due to constructive interference, same sign wave function should overlap. Then the chosen axis will form pi bond or sigma bond. I think that depends, no? Constructive and destructive interference will tell you something else, and this is telling you something else. That is a different concept. Okay? This is a concept that whether it will form sigma and pi, you can tell only from this thing. From constructive, destructive, you can't tell whether it's sigma or pi. Okay? Sigma and pi, you can only tell from this method. Constructive is just like in constructive wave. For example, this is let's say this is positive, let's say this is, okay, let's talk about not this one, let's talk about this one. This is positive, this is negative, this is positive, this is negative, right? Constructive interference means they will have lobe like this, right? They will overlap and they will not cancel the electrons. Destructive interference means this will be negative and this will be positive. They will cancel each other, right? And that's why here you will have empty orbitals here. Right, that will happen, right? So constructive and destructive is a different thing, and this I am teaching is a different thing. Okay, so let's talk about d pi. Now very important concept we are talking about. Very important concept. Okay, let's talk about that. This concept is that when it will form sigma, when it will form pi, when it will form delta. What is delta? See, when this is your d orbital, okay, let me just draw it. Okay, this is your d orbital. This is another lobe of this d orbital. This is the d orbital. Okay, this is the other d orbital that it is combining with. Okay, now let's name it. Let me see if okay, so I'll just show you this in a better way. if I say this is 1, this is 2, 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 right? If 2 is combining, overlapping with 1, 2 is overlapping with 1, that is called pi, okay? But what if you have this, I'll just draw it like this, wait a minute. If you have this is d orbital, this is another d orbital. I am not yet showing that they are overlapping, okay? If I name it, this is 1, this is 2, this is 1, this is 2, this is 1, this is 2, this is 1, this is 2. Okay? Firstly, understand this in 2D. If 1 is overlapping with this 1, 2 is overlapping with this 2, this 1 is overlapping with this 1, and this 2 is overlapping with this 2. That is called as delta bond. Okay? That is called as delta bond. Ma'am, what do you mean by that? Okay, let's see this. This is a d orbital. Okay, how should I make it? Just give me a second. Okay. Let's see. Okay. This is, let's say, this is one d orbital. This is another d orbital. This is another d orbital. Okay. Very hi-fi pen we have here. Right. This is one d orbital. This is another d orbital. Can you see that? These are the two d orbitals. If they are overlapping like this, I'll just show you here. Yes. Okay. Yes. If you see, this is the pi bond when they are overlapping like this, right? When they are overlapping like this, this is the pi bond. Can you see? This is overlapping with this, this is overlapping with this. So when they are overlapping like this is pi bond, sideways overlapping. But when they are overlapping like this is first d orbital, this is second, and they are overlapping like this. Okay. Now if you see, this particular orbital is overlapping with this orbital. These two are overlapping. These two are overlapping. Then, wait a minute. These two are overlapping. And here, these two will be overlapping. Right? So can you see? So this is delta bond. Right? That's why I told you. 1 will overlap on 1, 2 will overlap on 2, 1 will overlap on 1, 2 will overlap on 2. Understood? Yes, everybody? Is that clear? What is your delta bond? Okay, so let me just show you that again, right? Okay, let me just show you that again, right? Before teacher day, Jiva, when you say things like that, you are insulting that person, which I also respect really. I really respect that person, right? When before teacher day, you are comparing and doing all these things, right? That shows that you are not actually their student, right? If you would have been their students, these things you would never say, right? Okay? Good teachers raise good students, and when a student says things like that, they are definitely, you are not able to become that person that he wanted you to become. Sorry Jiva, sorry about that, right? So this is d orbital, this is d orbital. When they are combining like this, when they are overlapping like this, it is pi. When they are overlapping O on each other, this is called delta. Okay, right everybody? Prem Lata, this is what I told you, yaar. First bond will always be sigma. These are experimental observations, guys. First bond will always be sigma in pp, second bond will be pi, third bond will be pi. Let's say you have a p orbital where only one unpaired electron is there, it will form sigma. Let's say you have a p orbital where you have two unpaired electrons, one will be sigma, next will be pi. If you have three unpaired electrons, first will be sigma, other two will be pi. That's why this will form a single bond, this will form a double bond, this will form a triple bond. Okay? Got it? Now, let's talk about, ma'am, when it will form delta, when it will form pi, right? These all are experimental observations. I am just telling you what is delta, right? So, when this overlaps like this, that is called delta bond. When it overlaps like this, that is sideways overlapping. This is head-on collision sigma. This happens in only SS, PP and SP. This is your sideways. This happens in PP and DP, D and P orbital, right? Now in D and D orbital, you have pi also and delta also. Pi is when it happens like that. When it is happening like that, that is called your delta, right? Okay, understood everybody? Understood, right? Now I am going to tell you some very important points regarding overlapping. Tell me if that is clear, right? Okay. Already answered, Premlata, right? See this. If I talk about this, DD overlapping, delta bond, dz square cannot form delta bond. Can you tell me why? Because for delta bond, it's not possible that you have one orbital like this and the other orbital like this. It can only form pi bond. For delta bond, it should be overlapping like this. For that, you need to have two lobes here. Means you need to have total double dumbbell shape you need to have. In dz square, you have this kind of situation where you have only dumbbell shape with electron cloud. Because of this situation, it is not able to form delta bond, right? Only dx square minus y square, dxy, dyz and dzx. The one which has double dumbbell shape, the one which has double dumbbell shape, only they, double dumbbell shape, only they will form the delta bond. That's it. Got it everybody? Got it? Next is O2. Let's discuss about the overlapping here, right? So how the overlapping is going to be in O2. So situation with O2 is like this. You have oxygen, it is 1s2, 2s2, 2p4. When you make the bonds here, orbitals here, this is 1s, 2s, 2p. Fill in the electrons, 1, 2, 3, 4, 1, 2, 3, 4. Now if you see this here, only two unpaired electrons you have, and they will form two covalent bonds. And I told you, if you have two empty orbitals, one will be sigma, other will be pi. Okay, how it is going to be? You will have, this is, let's say, px, this is also px. So because of head-on collision, they will form sigma bond. Let's say this is py, this is also py. they will, because of this overlap here, they will form pi bond here, right? So that's why in O2 you have one sigma and one pi bond. Is that clear? One sigma and one pi bond. Okay. That ma'am, doubt in internuclear axis, ma'am. Once you make discussion about that, ma'am. Internuclear axis where? Internuclear axis in which part of the syllabus? Acha, tell me if that is clear. Is that clear, everybody? Is that clear? Right? Okay. Now let's talk about this. Strength of overlapping. Strength of overlapping. See, strength of overlapping is the extent of overlapping depends upon two things. First is nature of overlapping. Head-on collision always have greater as compared to sideways. Head-on collision will always have more as compared to sideways. Strength will always be more for sigma bonds. We can simply say sigma bond is greater than pi or delta bond. Okay. So this is your sigma. These three are corresponding to sigma. This is corresponding to pi. So always sigma bond strength will be greater, and that too in sigma you will have PP, then SP, then SS. Right? Now let's talk about some tricks here so that you can answer anything if they ask you regarding the strength. Okay? Okay? Yes, everybody? Huh. Okay, let's talk about that. Let's talk about that. Now students, see. For head-on overlapping, if you talk about head-on overlapping, let's talk about this, okay? Let's talk about this. For head-on overlapping, for example, if N1, N2, what is this N1, N2? Let's talk about that. Let's say I have 2S, I have 3P, 2S or other, it can be 2S, 2P, right? 2S, 2P and 2P, 2P. Now what is N1 plus N2? This is N1 and this is N2. This is N2. This is N1 and this is N2. This is N1 and this is N2. So N1 plus N2, in all of this is a trick, guys. This is a trick, okay? This is 4, this is 4, this is 4. So N1 plus N2 is coming out to be 4 in all the cases, right? If it is coming out to be 4, the answer will be, if N1 and plus N2 is same, in that case just apply this, then PP, PP, SP, then SS. So it will be 2P, 2P, then 2P, 2S, then you will have 2S, 2S. Okay? Got it? If N1 plus N2 is same, then PP, then SP, then SS. Okay? PP, SP, SS. Right? Understood? Kirti will talk about that, right? We'll talk about that. Firstly, please understand this, right? Okay? Yes. Now, for head-on overlapping, if we have N1 plus N2 is different, in that case, lower the value of N1 plus N2, higher will be the overlapping. For example, you have 2S, 2P, you have 2S, 3P, right? Then you have 3S, 3P, right? then you have 3s. So let's talk about this one. Okay, in this case, what is the value of n1 plus n2? This is n1 plus n2 is 4, n1 plus n2 is 5, 2 plus 3 5, 3 plus 3 is 6. So higher the value of, you just have to see, in this case don't see anything, just see higher the value of n1 plus n2, lower will be the overlapping. So that means maximum overlapping has to be here, then here. Because n1 plus n2 is inversely proportional to the overlapping. n1 plus n2 is inversely proportional to the overlapping. Okay, everybody? Got it? Very good. Next is for sideways overlapping. For sideways, I'm facing some problem in my throat right now. Whew. I think I'll have to end the class, guys. I'll take one extra class tomorrow. What I'll do now? I'll take 1 hour class tomorrow for hybridization and the rest part of overlapping, and then I'll take class on Saturday and Sunday also. Okay? Got it? Because I'm like not able to talk that much. So now here we discussed about axial overlapping. Axial, that means head-on collision. Here we are talking about head-on overlapping. This is a criteria for head-on overlapping. But when we talk about sideways overlapping, things are very different. Okay? So in sideways overlapping, let's discuss what you will have. In sideways overlapping, let's discuss what you will have. In sideways overlapping, right, if n1 plus n2 is same, the trend will be like this. What do you mean by that, ma'am? If n1 plus n2 is same, the trend will be as it is, right? 2p, 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 3d, 2p, 3p, 3p, 3p. Beyond this, they will not ask you 2p, 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 3d, 2p, 3p, 3p, 3p. Just write 2p, 2p, 3p, 3p. Right? Now here write 2p, 3d, this will be 2p, 3p. And that's how you have the strength. Okay? This is in case of sideways overlapping. If n1 and n2 is same, in that case pp, pd, pp, pp. Okay? Understood? When 2p, 2p, right? 2p, 3d, then 2p, 3p, then 3p, 3p. Okay? Yes, everybody? Next is for sideways overlapping, if n1 and n2 is different, so simple thing is lower the value, higher the overlapping. Let's discuss that. Okay? Let's discuss that. Here the value is 2 plus 2, that is 4. 2 plus 3, 5. 2 plus this, 5. 3 plus 3, that is 6. Now, in these two cases, we know that from this to this, why it is decreasing? Because n1 plus n2 is inversely proportional to overlapping. Now, if you talk about P, D and PP, PD is greater as compared to PP. Okay? PD is greater as compared to PP. Okay? Even though n1 plus n2 is same, even then this is the trend. And this trend here is because n1 plus n2 is different. Okay? Anjali, we were talking about only this case, okay? Only this case. Only this case. Here it is 4, 5, 5, 6. These two 5 are equal. So here what will happen? PD, like in that case also when n1 plus n2 was same, we know that firstly we had PP, then we had PS, then we had SS. In the same case, if N1 plus N2 is same, you have PD and then you have PP. Okay, because these are the two bonds that you form in case of pi bond, right? In case of pi bond, right? If there would have been DD, then PD, then PP. Okay, right? Remaining क्या बेटा? Remaining any question when you have same N1 plus N2, right? DD, then DP, then PP. Okay, right? Understood? This is how they overlap. In case of DD, the overlapping is very high as compared to PP. Okay? You will see the structures when you see the lobes here, right? The overlapping extent is more in case of D. Okay? Got it? Everyone? Got it or not? Which exception I am talking about? I am not talking about any exception. Which exception? I am not talking about any exception here. Which exception you are talking about? Then why they give ma'am 2 p pi is not equal to 5? No ma'am. Beta, chalo, I'll do that. I'll erase this, right? I'll erase this. This was just an example of both the cases, okay? What I'll do here, I'll just erase this. Okay. When this is same, we will not take this example. Let's take it like this. Okay. Right? Now is it same? That is just an example, okay? This is 5 and this is 5. If N1 plus N2 is same for sideways overlapping, firstly you have PD, then you have PP. Okay? Understood? Now, when I am saying it is same, now let's do one thing. Rather than writing this, I'll say when it is same. Achha, when same, so we have seen, no? When it is different, then let's talk about this. 2p, 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 3d, 3p, 3p. 2p, 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 3d, 3p, 3p. Okay? In this case, this is 4, this is 5, this is 6. And now, that's why it is going to be this. Right? I just combined these two things and made this thing. Okay? I just combined these two things and made this thing. Got it? Now understood? Here it is same. Here it is different. So firstly we wrote it for different. That was coming out to be this. Now 2p 3d and 2p 3p is same. So then we will apply that PD is greater than PP. Okay, right? Okay, everybody. Tell me guys if that is clear or not. Tell me guys if that is clear or not. Okay. Chalo. Now guys, I'll just end the class here only because my health, we have few more things here. So I'll do that and after that I'll end the class. Okay. I'll do this after rest of the part, overlapping part and hybridization part we'll do tomorrow. Right. I'll see if I can take your class. I'll take your class at around something 9 p.m. or something, right? And we'll finish this. Just 1 hour class I'll take tomorrow, right? Because the doctor has advised me to speak less, to talk less. So continuous long classes is tough for me. Okay. So it is SS. See, when you have two s orbitals, right? Sigma bond is formed, internuclear X's. Now I think Kirti was talking about this part, isn't it? Kirti, were you talking about this part, internuclear X's? Were you talking about this part, internuclear X's? So let's see. SS, right? S orbital. Whether it's coming from 2s orbital or 2y or 2z, it will always form sigma bond, right? Always it is going to form sigma bond. S and px. This is px and this is s. It will form sigma. This is py and this is s. It will form sigma. This is pz and this is s. It is again forming sigma. It is coming like this, okay? So it is head-on collision. So, right, that is your sigma bonds, right? Now, if you talk about this px, in that axis should be x-axis. Can I say axis is x-axis? Py, it is y-axis. Pz, isn't it z-axis? Yes. Okay, so that is the concept of internuclear axis. Tell me first page is clear. Okay, so x-axis is, now sometimes some teachers take this as x, this as z and this as y, right? But here I am taking, in this case I am taking this as x, this as y and this as z. Okay, now understood? These are simple x's. Now this is going to get more complicated, right? Okay. Yes. Now, tomorrow the classes definitely should be there, right? So because, ma'am, what is tomorrow? Then is orbital. Let's see px and px. That means this is px and this is px. So we know that this is along the x-axis, right? So that is why internuclear x's are x-axis. Py is, it will be like this. This is Py because it is forming sigma bond, okay? This is forming sigma bond. So it will be like ma'am, but ma'am, Py, ma'am, always it forms sideways. No, Py can also form sigma, right? It depends at how it is overlapping. If it is overlapping like this, it will form pi. If it is overlapping like this, that's what I told you, right? If it is overlapping like this, it will form sigma bond. Pz and Pz, this is one Pz, this is another Pz, it will also form sigma. This is along z-axis, this is along y-axis, this is along x-axis. Isn't it? Thank you Vrat, thank you Premlata, thank you so much for your wishes. And thank you Tilak. Okay? Yes. Don't worry, Kirti will talk about that also, right? That constructive destructive is very simple. Okay, we'll talk about that also. Now, Pz and dz square, right? Now, in case of Pz, if you talk about this, Pz is like this, okay? Pz is this. It needs to form a sigma bond. Can it form a sigma bond? Yes, if you have z square like this. If this is the z square and this is the electron cloud. Okay. So they can also, if this is Pz, this is dz square. They can also have head-on collision, right? So they can also form sigma bond, right? Again, it is along the z-axis. Then if you have px and px pi bond, very interesting. Px and px pi bond. This is px and this is px. See, this is also px and this is also px. Now, if px and px are forming pi bond, it will be like this. This is the pi bond that they are forming. Can you see this is along y-axis or this will happen along z-axis, right? If 2x, px, they are not making collisions like, they are not overlapping like this, they are overlapping like this. Now, this particular bond can either be along y-axis or along z-axis, right? If you see it in 3D, y-axis still you will be able to imagine, right? So, that can also go along z-axis, right? That bond is like this, okay? So, here except for, the trick is except for this x, the remaining will be your x's. Except for this y, remaining will be your x's. Except for this z, remaining will be your x's. That is a trick, okay? Because imagining this in 3D every time is tough. Now in y and y, you can imagine it like this. It can be along x-axis or y-axis. The overlapping can be along y-axis or z-axis. The x-axis or z-axis. The orbitals are, now how should I show you this? Wait a minute, let me see if I can show you that. See, okay? I'll just try to answer one of them. Let's understand this is, let's say this is x, this is y and this is z, okay? So along y-axis you have two orbitals, first and this is the second. They are showing overlapping, they are showing overlapping. So now either this overlapping, can you see, either it is going along x-axis, or if it is like this, this is y and this is, how should I show you z-axis then, you know? You should understand it is going like this and it is outwards, okay? I'm going to show it like this. This is z-axis, okay? I'm going to draw it on 2D, 3D. This is z-axis, this is y-axis, this is x-axis, isn't this your z-axis? This pen here is your z-axis. If one orbital is like this, other orbital is here, let's draw this orbital like this, okay? Let's say this is your z-axis, okay, and this is the orbital. Now if this orbital and this is also an orbital, if they are overlapping, aren't they making a bond along z-axis? I don't know if you are able to see this or not. Aren't they making a overlap along z-axis? Can you see that? Can you see that, guys? Can you see that? No, Kirti, they can make pi bond. They can make, if px and px are overlapping like this, they will make sigma bond. If they are overlapping like this, px and px are overlapping like this, then they will make a pi bond, right? It depends upon what is the situation. But for theory part, we always say that first, usually we take py as pi, but there is no, it's only by convention. Otherwise, px, py and pz are same only. It's only that x's are different here. So, by convention, we take first as sigma and next two as pi. That's why you must always think that px is sigma and py and pz is pi. It's not the reality. First bond will be sigma, other two will be pi. Okay? Got it? Yes? Right? Got it? Can only make pi bond. Understood now this concept here? Why I am taking x's as x or z? This I have taught you here. That if this is y, in 3D, I can also say, if I say this is the pi, this is pi, this is py, this is also py. Now they will make this bond along z-axis. No doubt they are py, but along z-axis they can overlap. But if PYs are like this, then they will make along x-axis. Can you see this is x-axis, right? So that's why internuclear axes are x or y, okay? Right? ठीक है जी? So in 2D, so it is tough to teach you, but in 3D, I think it is better. Right? That's why I'm writing it like this. Okay, so I'm just deleting it because in 2D, you won't be able to understand anything. Right? So simple trick is whatever is written here, except for that you have your x's. If this is PZ, internuclear x's are x or y, right? If you have px and dxy, px and dxy, tell me that. This I'll make here. This is z and this is z. Okay, chalo. Now px and dxy. Let's understand that. I'll just make this bond here so that we have space. Px means this thing and dxy, that will be like this. Okay. Now if dxy wants to make a sideways overlapping, it can always do things like that. 1, 2. Isn't it a side, isn't it a side, no, it's not a sideways overlapping, wait a minute. Px and dxy can make sigma and pi bond both. If it is making pi bond, it will be like this. This is px and this is xy. Can you see that? Can you see that? They are not colliding like this, they are like this. Can you see that? This is x and this is dx. They are colliding like this. Overlap is sideways. Overlap is sideways. Okay? So now it is sideways overlapping. Okay? Sideways overlapping. Okay? Right, everybody? Got it? Now, let's talk about px and let's talk about the internuclear axis. Simple funda is, if here you have x, trick I am telling you because in 3D it is very difficult to visualize that thing, right? So just simple trick is, if this is x and this is xy, cancel this x, you will have y. That is your internuclear axis. Okay? So when you have px and dzx, same thing will happen. Xx you cancel, you will have z. X, here you have nothing common. Can you see nothing is common? So it can be y also, it can be z also. Right? Okay? In this you have y common, so it will be x-axis. In this you have y common, so you will have here z-axis. Right? So this is how you are making this pi bond here. This is how you are making this pi bond. Right, everybody? Okay, same thing will happen here. Right, sideways overlapping. Sometimes it will be like this. For example, let's talk about py and d, xy and yz. It will be like this. This is the sideways overlapping. Right? Okay? Got it, everybody? Shall we move ahead? Right? Now, next is, wait a minute, is it copied? No. Right, same thing here. If all of them are different, it can be x or z. If it is different, it can be x or y. If it is same, z will cancel, it will be x. It is same, z will cancel, it will be y. And it is all going to form a pi bond. Because, wait a minute, sorry, I think by mistake I told you that D and P will form sigma. They will never form sigma, they will form pi bonding. Okay, they will always form pi bonding. Right? Okay, yes, everybody? Huh. Understood? Chalo. P and D will always form pi bonding. Always it is going to be like this. You take any case. Let's take the case of Z here. Okay. So Z is like this. Okay. Z is like this. So it will form a pi bond with X and Y. right? How it is going to form a pi bond with x and y? Let's see, this is x or y. If I draw x and y here, if this is x and this is y axis, if I take it like this, it will be like this, okay? So how it is going to form? This is how it is going to form the sideways overlapping, okay? This is how it is going to form the sideways overlapping, right? Okay. Now, last one, another pi bonds that we have between D and D, right? So, x is how you will understand, xy is given, so it will be x or y. Yz is given, so it will be y or z. Zx is given, so it will be z or x, right? So, whatever if both are same, only then they will form the pi bond, right? Because let's say if this is xy, right? It is going to do sideways overlapping with another dxy, right? Similarly with yz, similarly with xz, same thing. Now, last is your delta bond. Delta bond I have taught you, it will be like this, okay? So, in that case, if you have xy, overlapping is like this. So, overlapping will be on that internuclear axis which this does not have. So, if it is xy, it will be z. If this is yz, it will be x. If it is xz, it will be y. So, if you want to see it in 3D, because this is not that easy, right? So, I'll just show you here. This is y, this is x, this is z. Now, throughout this chapter, take this x, this y and this z, right? If you say this is z ma'am, this is y, then you will start getting confused, okay? You should have one thing constant in your head, okay? Otherwise, you can also take this as x, this as y, this as z, whatever you can take, but I am taking like this, so have this in your head. Otherwise, you will start getting confused. Now, if I draw the orbitals here, that is xy, right? I am drawing xy. So, this is, wait a minute, this is first, this is second. Similarly, you will have this one, first, and you will have second. Now, I am saying they are in front of each other, right? Okay, so I think it's not possible to teach you that in 2D. I just realized that. If this is overlapping, can you see, if I say this is x-axis, so I'll just draw the x's here, okay? I'll just draw the x's here. Oh. If I draw the x's, this is y, this is x, and this is z. Okay, this is z. If I am drawing these x's, okay. Now, if you see this, I am just mentioning here that this is y, this is y, this is x, and this is z. Okay, if I am mentioning these x's here, then what will happen? See this. If I am mentioning these x's, okay. So, if I had these kind of bonds, if I have these kind of bonds, now what I'll do? I have these, right? Now they will form a delta bond like this. Isn't it? Delta bond is formed like this with the overlap 1, 1, 2, 2, 3, 3, 4, 4 overlap. So if this is x-axis, if I say this is x-axis and this is means this is dxy. So this was your dxy, okay? Let's imagine this was your dxy and overlap of another dxy, which I am drawing with the highlighter, overlap of another dxy, right? That is happening. Dxy, dxy. Overlap of it is happening. Can you see? If I say dxy, dxy, from here I can see if this is x-axis and this is y-axis, this is y-axis, this is x-axis. If I draw it like this, overlap is happening here, overlap is happening here. isn't the overlap happening on the z-axis side? If I see it from this side, this overlap is actually happening on the z-axis side, right? So the internuclear axis will become z-axis, right? Okay, so you have to imagine this in 3D. Okay? Okay, got it. Yes, everybody. So that's why for xy you have z, for yz you have x, for zx you have y. Okay, yes, everybody, got it. Understood? Understood? Right, these are the differences that you have, right? Okay, these are the differences that you can read yourself also. It is formed by end on end. It is sigma bond is shown by these orbitals. It is a strong form. It is symmetrical. It consists of one electron cloud which is symmetrical about the internuclear axis. That I'll teach you in the next class. Free rotation about the sigma bond, that also we'll talk about in the next class. Okay, so these things we will talk about in the next class. Little part of overlapping we are left with, and then we are going to do hybridization. Okay, yes, everybody, then we are going to move towards wait a minute, let me just, I thought today we will do hybridization also, but that's not possible. So the correct order of overlapping extent for axial overlapping is going to be which of the following? That is your homework question, everybody. And I want you guys to write it down in the comment section, your homework as well. Right? Now I'll see you all tomorrow. We will do hybridization. Very simple concept it is, hybridization. We'll move towards not Vesper theory, but yes, we'll move towards Vesper theory actually. We'll move towards Vesper theory, okay? We'll move towards Vesper theory. Rest of the part, right, we'll do in the next class. Almost overlapping is done. Hybridization we are left with, and Vesper will start, right? Vesper, and then we'll start with VBT also, right? Okay, yes. Kirti, I'll do that in the next class. Okay, we'll do that in the next class. Positive overlapping, negative overlapping, very simple, that is constructive, destructive. Hardly it will take us 5 minutes to cover that. Okay, right? Chal. Okay then guys, now I'll see you all in the next class. But before going, remember that our MVSAT scholarship program is going on, which is going to held on 4th, 5th, 11th and 12th of October, right? And in this mega Vedantu scholarship program, the registration is totally free of cost. And guys, what you can do, just click on the description link. Link is in the description. Click on that, register yourself and give these tests, because you are going to get 150 crore worth scholarship. You will get 2 crore worth rewards and prizes, right? iPhones, iPads, all these things you will get. Study material is totally free. All online, offline courses are totally free. Counselings will be free to you, right? All the things will be free, right? So, right? And one more thing. So, tomorrow is Teachers' Day. So, we have a very amazing surprise for you, right? That will be at 6 p.m. on this particular class. Okay, yes everybody, okay. Okay then guys, bye bye, take care, and I'll see you all in the next class. Bye bye, bye bye.